Our talk is going to focus on typical typos. My name is Amir Kirsh. I will just start with something I guess you already saw. The meeting is being recorded, which means that you can feel free to participate. This is a Zoom meeting, which means if you want to use the chat or if you want to ask to be unmuted, we will have an interactive session. Feel free to participate. In order to participate, we have here Tim, our track host. So if you just raise your hand, I mean raise your hand virtually, or ask to be unmuted via the chat, Tim will unmute you or allow you to be unmuted, and then you can ask questions in your voice. But please be noted then, at this point, you will be recorded. Also, your chat is being recorded with your actual name as you logged in with. And now, after saying this disclaimer, I think we are ready to start. A few words about me. I'm a lecturer at the Academic College of Tel-Aviv-Yaffo and at Tel-Aviv University. This talk is a bit related to my role as a teacher, as a lecturer, and I will share it in if you like later during the talk. I'm also a member of the Israeli ISO C++ national body and the co-organizer of the Core CPP conference and meetup group. Previously, I had many development and management roles in the industry. The last one as the chief programmer at Comverse. Our talk is about typical typos, which would be focused on common errors that relate to bad use or bad implementation of types. And I do meet these errors while mainly checking students' assignments. And some of these errors are quite tricky. And eventually, even though we educate the juniors, these errors would skip into actual code in the industry. So you should, in a way, see this lecture, see this talk as a way of thinking, what should I look for in my code review? What things can get into our code, and I should pick an eye on that and see whether it is in, how can I avoid it? And we are talking about bad design, inefficiency, undefined behavior, bugs, and compilation errors, because compilation errors are being tracked, are being recognized by the compiler. But in many cases, juniors, when they get a compilation error, they just fix something without, in many cases, knowing what exactly they changed. And now the program is being compiled, but they just put inside an actual bug. So without understanding why the compiler was mad at me, what was the actual problem, we may put in an actual bug. It is worth mentioning, just before we start, that there are tools to come before the code review or before trying to mitigate, to find problems by ourselves. And this is firstly compiler warnings. And you should remember that -w all is not all warnings. So consider opening, for example, pedantics, extra, and other warnings. Static code analysis tools do find some of the problems that I would present here today. And of course, best practices. Knowing the best practices help you while you are coding, while you're doing code review. And I'm going to, of course, in this presentation, go through a partial list of issues. So if you want to cover a greater list, going through best practices is a very good approach. Also, before we start, some of the slides would be annotated with a skip sign, which means that we may skip them if we don't have time, so don't feel too bad about that. It was planned ahead. You would have access to the slides, so you can later on pay some more attention to such slides. And last note before we start. It's a game. it's again because you are going to participate as an active audience. You are requested to count your own points, but you must submit your answer before my answer is revealed in order to count your correct answers. And when I'm taking my answer as the answer that you should count as correct, even if you disagree. So I think that now as we know the rules, we can just warm up, and let's warm up with a question that you would not count. This one is not for counting your points, but still, get ready. Here comes the first question. So the question here is, don't count the answer here. This is just for a warm up, but the question is, there is a question here by someone whether there is a problem with the sound. I think that the sound is fine. Other people are hearing the sound. So maybe this can be checked with the technical team. So what is the problem with this piece of code? And here comes the 4 answers, which would in this case mainly check if the audience is more Brits or Americans or others. And you can cast your vote now. So you have now the poll. You can select the correct answer as you see it. This will allow us to understand whether we have more Brits than Americans or vice versa, or a mix. And in a few seconds, we'll just understand whether you prefer to write initialization with a Z, with a Z, or with the S. Whether behavior comes with you or not, at least for this audience. So let's give you 5 more seconds. And I think that we can reveal the results. And it seems that B is winning. And B says that behavior should come with U and initialization with S. I think more Brits here today. Okay, that's interesting. So after this question, I think that we are ready for the actual questions and view it as a kind of a code review. Are you ready? Let's go on. What's wrong here in this piece of code? We are focusing on the loop, on the range-based for loop. There is something wrong in this loop. Either a dangling pointer or inefficiency, a potential leak, or a compilation error. One thing which is important, in order to count your points, the important part is that you are casting your vote, even if you're guessing. So if you're not sure, just take an educated guess, use your intuition, it's fine. It's okay to count the points, even if it was just a guess. We'll give you 5 more seconds. And I think that we are ready to close the vote and share with you the results. And I would say that about half or a bit less than half said B, inefficiency, but many others missed that. And the problem here is indeed that there is inefficiency in this piece of code. And what is the inefficiency? The inefficiency here is that the actual type that is being returned in the range-based for loop is not a pair of k and v, of key and value, it's a pair of const key and value. And when we are asking to get a pair of key and value, we are getting through casting. And the casting creates a temporary pair with a temporary key and a temporary value. So we are creating, during the loop, temporaries for the entire collection, which is quite costly. This is why auto should work here fine. If you just follow the when should I use auto, and the big shots of the language say use auto anywhere. Why? Because auto will assist you in avoiding such bad casting, such inefficient casting. So either you add const to the key or you use auto. Either one of them is a good option. I would say that the big shots of the language would say use auto. Even nicer might be to use C++17 structured binding and say, okay, you know what? Let's get the key and the value by reference out through the range base 4. And this is also a possibility. So here we have some related links that you could use when you access the slides. How much auto is too much? The Google slide guide, the Google style guide on auto, what the big shots of the language say during some conference 2012. And we're ready, I think, to go to the next question. You do remember, I guess, I hope, to count your correct answers. So the next question is in a similar code, but here we use auto in the for. But the question is on the signature of the function. We have here a function called print. We want to print a map, stud map, and this is the stud map that we want to print. We want to print any stud map. So the function is using templates in order to capture any kind of a stud map. What is the problem? What's wrong here? And the answers say const issues. You have here const issues, or you should use forwarding, or the code is not generic enough, or there is some kind of a bad style in this code. And again, we're focusing on the signature of the method. Let's give you a few more seconds to think about that. Again, something is wrong, something is not so good with the current signature. And let's share the poll results. You see that C is the most selected answer, which is the actual answer. The actual answer is that the problem here is the code is not generic enough. And why is that? We do use templates here. Well, the code is not generic enough because if we want to send stud map, which is using another comparator which is not the default comparator. That's just, for example, if we just use map with greater, stud greater, instead of stud less, then we'll get a compilation error. And we get a compilation error because we didn't provide the third or the fourth template parameter, which is part of stud map, which means that the signature says, okay, I'm going to accept any stud map, which has any key and any value, but you didn't say anything about the two other parameters, which are the comparator and the allocator, which means those should be as the default provided by stud map. And once we provide something which is not the default, the code doesn't compile, which is not generic enough. So the solution might be simple. We can say, okay, we want to get stud map of k, v, and some additional args. We can just say the other two arguments, but here we are using variadic template for the other two arguments, and the other two arguments can be provided or not. If they are not provided, then it means that we do use the defaults from stud map. If they are provided, it means that we are ready to get another stud map, which is not a stud map using the default comparator. Another option might be this one. We might say, you know what? We prefer to support any kind of a mapping collection. So in order to support any kind of mapping collection, we can say that our function accepts a map, which is a template parameter, being templated on k, v, and other additional arguments. And the question here is, what is wrong with this approach? And you can answer in the chat. This is not a multiple choice question. It is not counted. What is the problem here? If we want to be a bit more generic, meaning we want to support not only stud map, but any mapping collection. So we say, okay, a map of something. And what is a map? A map is a template parameter being templated over k, v, and some additional arguments. So we have an answer here from Dimitri saying that it could be templated over other types which are not mapping collection. And I would say that the problem here is that this signature is too greedy. Too greedy in the sense that any class which has two template parameters may go in. And we don't want that. We want to get only mapping collection, and we can do that by requiring the mapping type to be type that complies to mapping collection requirements. And there are underneath two links to possible ways of how to achieve that. But it would be better to restrict our parameter to actual mapping types. Okay, so we discussed being too generic or being too greedy, and the correct way is to have a proper parameter being templated over the proper types. Are you ready for the next question? Again, think of that as a code review. What is wrong here? We have here a simple function getting something. We are not asking about the signature of the function. The function gets auto, which is a bit too generic. Let's put that aside for a moment, okay? And let's ask, what is the problem with the printing? We are approaching first and second. And here are the answers. We have something here with a dangling pointer or inefficiency. Maybe there is a potential leak, or maybe we have here a bad design issue. The answers are coming in. We'll give you 3 more seconds. And we can share the results. Most of you say that the problem here is bad style or bad design, and indeed this is what I say also. And the bad design here is twofold. It's twofolded. First, we have a language issue. There is here a bad design in the language itself. First and second are a language accident. They are considered as a language accident because the language exposed two data members. The proper way should have been to have functions. And why is it a problem? Because once you have it as a member, as a data member, a data member is much less generic in the way you can use it, in the way you can write new code. Suppose you want to create your own pair, and you want your own pair to behave the same as stud pair. So you have to expose first and second, but your second is not a number. Your second is the result of first square, and you want it to be calculated lazily. It's a problem. It's doable. It's doable using a proxy class, but you have to work on it a bit harder. It would be cumbersome. If it would be just two functions, it would be much easier. So there is here a language issue by using first and second, but that's what it is. You know, pair is using first and second. Can we do something else? Well, we could. We could. The problem is in the language, but we could also do something in our own code. Well, our own code is using first and second, and we have here two problems. The signature is too generic. Let's put it aside. This was not the question. But printing first and second is not generic enough. It is not generic enough because we support only std stud pair. We do not support, for example, stud tuple, even if we have here a tuple with two, a tuple of two. Okay, so if we want to support tuple of two and stud pair and any other combination which has the ability to provide a first and second, but not as members, because, for example, tuple doesn't have the first and second members, we could use the get API, which works for stud pair, stud tuple, and stud array, and other user-defined types, which apply for tuple size, tuple element, etc., and then provide the get. So this is a better approach. And if we want to be not so generic, we don't want to be so greedy, and the greediness here is not so a problem because the function is called print pair. But yet, it might be better, maybe even to call it print and get a pair and restrict the pair, for example, with concept, with a proper concept, saying we are getting here only something which is a pair. But this is another question. The question was, what is the problem with the printing? And I would say using first and second is firstly a language accident. Don't do that with your own types. Hide your members. And the second thing is, once you use pair, prefer to use the get API instead of first and second, in which case you open your code for the possibility that a tuple would be sent here. Let's go for the for the next one, and I'm reminding you that you need to count your points. What's wrong in this code? What's wrong in this piece of code? We have a zero initialize all function. The function zero initialize all is getting a container and is going through the entire container doing a zero initialization via assignment in order to zero initialize all members, all items, all elements of the container. And the options for these questions are: the first auto should be auto double ampersand, or the second auto should be double auto ampersand, or the second auto should be by value, or the first auto should be by value. Please cast your vote. It's a bit tricky. It depends on some behavior. The question depends on some behavior of a specific collection or a specific container that we want to support, and it is not, this specific container is not supported in the current code. So we'll give you a few more seconds. Last option to cast your vote, and let's reveal the answers. So most of you selected B, and the correct answer is indeed B, and let's explain that. The second auto, being with only single ampersand, means we are expecting to get here L value reference, which is quite reasonable. We need here to write, to assign into val, which means we need L value reference. Can it work with R value reference? Well, surprisingly, yes. R value reference can appear on the left. We can have on the left side of assignment R value reference. And the other point is that double ampersand here doesn't mean R value reference. Double ampersand here mean forwarding reference. Double ampersand on auto is like double ampersand on the template parameter, which means it can be based on reference collapsing rules, R value or L value. And why is it important? In order to support vector of booleans. Vector of booleans is a special creature. It is based on specialization, and it returns, when you approach an element, a proxy class, a proxy object. And this proxy object is returned by value, is returned as something that you can capture as an R value, but not as an L value. So the only possibility to support both vector of booleans and other containers which are not vector of booleans is to put here auto double ampersand. Now this, in a way, points out that vector of booleans is again a language accident. You should not do that in your own code. If we rephrase the list scope substitution principle to templates, we would say that one should be able to use the specialized version of a template the same way as using the base template without being aware of the exact type being used, which is the list scope substitution principle, which was originally for polymorphism, but here we use it for templates, for specialization, and vector of booleans doesn't correspond to this rule. It has a special behavior, which means you cannot use it the same way that you are using other vectors. So this is a language accident, which means that you have to beware of specialization. So let's talk about specialization and inheritance. This is quite a long code, longer than before, so we'll give you some more time. And the question for this is, what would this main print? So we have to read the code. I will just explain it shortly. We have here a struct called foo, and foo, as a struct being templated over T, as a print method, a static print, printing something. We also have a specialized version of foo, and the specialized version of foo is being specialized over pet. So if you are pet, you have a specialized version of foo. And foo of pet has a print which is printing pet. Now dog is being derived from pet, and the main is trying to call print of foo of dog. And then the question is, does foo of dog using the specialized version of foo of pet or not? Or maybe something else? Maybe this is a compilation error. What should happen here? And I think that you can cast your vote now. Well, it might be that my explanation here helped in a way, because I'm seeing now your votes. You still do not see, we did not share it yet. You can still vote. But it seems that many of you are seeing here what would actually happen. So let's give you another 5 seconds. I remind you that you can just guess, following your intuition. This is fine. And most of you answered A. And the correct answer is indeed A. And the reason is that specialization doesn't catch polymorphism or inheritance. And it doesn't even work if it was pointers. This is why, in order to implement is base off, you need something which is not specialization. You need other technique. Specialization doesn't work so well with inheritance. So be alerted. Okay, let's go for the next one. Let's put aside the specialization and go a bit for R value and move semantics. So we have here in this piece of code a class which has only RAI objects, which means only objects which manage their own lifetime. So because all our internal objects, all data members manage their own lifetime, we do not need a destructor, we do not need a copy, but we did implement a copy because we have a static counter that counts copies, and we want to count the copies. This is why we have the copy constructor here in order to count how many copies are created during our program. We added the default for the empty constructor, so objects could be created, but we do not have any other constructors or a destructor. And the question here is, what's wrong here? Do we see here a dangling reference or inefficiency, a potential leak, or compilation error? What do you see? Please cast your vote. You can see that we have the signature and some kind of implementation of the copy constructor. We have a default empty constructor. We defaulted the empty constructor. And all our members are RAI members, which means they manage their own lifetime. Let's give you another 5 seconds. Again, you can guess. And we're ready to share with you the results. Most of you are saying that there is here a problem of inefficiency. And again, you are correct. And the question is, where is this inefficiency? Well, the inefficiency is with not having a move constructor. We just missed the rule of zero. Once we created our own copy constructor, even if not for copying, we just had to, probably we need to copy because we have members. So we do need to implement the copying. But the main problem here is if we do not implement a move or we do not default it, then we do not have the move constructor. It is being implicitly deleted. So we do not meet the rule of zero. And if, for example, we have a vector of our class and the vector is enlarged and it goes beyond the current capacity, then all elements would be copied to the new location and not being moved. While we could have moved them because all our members are RI objects, which means they may have a better move operation than copying. So what should you do here? Simple thing, just default the move constructor. This is what you need to do because you add a copy constructor. Another better approach might be put the implementation of the copy constructor and the counter mechanism in a base class and inherit from it. And then you are still in the rule of zero. And you do not need to implement anything. And the copy in the base class just have to implement the semantics of the counter. It doesn't have to copy anything if it doesn't have any actual members. And then you are back to the rule of zero, which is the perfect approach here. And by the way, even if your base implemented a copy, which means that your base doesn't have a default move, it doesn't mean that the move is deleted for your base. It means, and it might be that I said wrongly in the previous slide, that once you have a copy, it means that your move is deleted. That's not the right semantics. I should rephrase it again. Once you have a copy, it means that you do not have the default move. You can bring it back, but you do not have the default move. Once your base class have a copy constructor, it means that your base class doesn't have the default move, but you can have the default move if you are in the rule of zero. This is not the same as having a base which actually deleted the move. If the move is being deleted in the base, this is another thing. In this case, you do not have a default move. But this is not our case. The base class have a copy. The default move is not apparently in the base class, but we can have it. So this is the correct approach. We are now to the next question. What's wrong if we actually did implement the move? Here we have a move constructor. We follow the advice. and we go and implement a move. Maybe we do need a move. Maybe the default move is not good enough. We want to implement move. So what do we do inside the move constructor? We do anything that is relevant here. Maybe we even have constructor initialization list. So suppose that if there is a need for constructor initialization list, either for the code to compile or for efficiency reasons, let's suppose that we do use constructor initialization list. And the question is, what's wrong here? So, team, if you can just pop up the poll and you can cast your votes. Again, the question is, suppose that we do implement move in some class, and this is the move that we are going to implement, with or without constructor initialization list, according to the actual need, whether we do need it, constructor initialization list, but this is the move. What's wrong here? So we have a type that needs a move, and it implements move. This is quite a short piece of code, so we'll give you 3 more seconds. Hurry to cast your vote, and let's share the results. And most of you are saying correctly B. What's the problem? What is inefficient here? Well, it's quite hiding there. It's not here, and it should be, and it is the no except. Move constructor should be no except. Because if it is not no except, if it doesn't say no except, if it doesn't have no except on its signature, it means that vector cannot use it when it needs to move from old location to new location. The reason is that once vector needs to move elements from old location to new location, if it copies, there is no problem. Even if the copy constructor would throw an exception, then the vector will catch the exception and propagate it to the user, still preserving the old vector as is, because we just copied. So if the copy failed, no problem, we still have the old vector. But if the vector moves the elements from the old location to the newly allocated memory, the bigger allocation, and during this move, one of the elements throws an exception. We have an exception during the move. So the vector is in a problem. The problem is part of the vector was moved. Part of the vector was not moved yet. We have here 2 allocations. Both are invalidated. So even if we propagate the exception to the user, and the user can, in a way, handle it, the vector is invalidated, which should not be the case. We should never invalidate the vector if we cannot copy or allocate the bigger allocation. And this would happen if move might throw an exception. So the C++ specification says that vector should not use move for moving elements from old allocation to new allocation if the move operation is not no except. You can try it yourself. There is a link here to an actual code. Take an example. Add the no except. Remove the no except. Enlarge the vector. You will see calls to copy constructor instead of calls to move constructor. And this is quite costly. You have a move constructor. You think that you are right, but your type does not really have a usable move constructor for the use of vector move. So follow that. Let's see, we have in the chat, does that only apply to vector in the standard library? It applies, I think, to any operation that needs move to be no except. So vector is known for that. We have to think whether other operations need move to be no except. I don't have here another example. For vector, the example is very known. We can think about other examples if there are. Let's go on. This is our next question. The question is, there is a rule saying if you want to copy, sorry, we just spoke about move, here we are speaking about copy. If you want to copy pass by value. Maybe you heard about since C++11, there is some kind of a rule, some kind of, I would say, approach saying if you want to copy, pass by value. Well, it's not a definite rule. It's not always true. Is it true here? Or maybe we have here a problem. What's wrong here? And the possible answers are dangling reference, inefficiency, potential leak, or a compilation error. Team, thank you. So you can cast up your vote. What do you see here? What is the problem? You can see that we have a stud set holding strings. And this method needs to insert into the set. So we know that somehow it might be that something would be copied or not, I don't know. So we say, okay, if you want to copy, get by value. What's wrong here? And 3 more seconds. Let's show the results. Most of you say inefficiency, and you are right. That's correct. Let's see why this code is inefficient. If you want to copy pass by value, but this code doesn't necessarily copy. Let's take a look. Suppose that the string that we have here already appears in the set. If it already appears in the set, it means that we would not copy it. So when we took the string and we moved it inside, so the copy was provided by the compiler. And why the rule or the approach is saying if you want to copy paste by value? Because in a way, we do earn here something. There is some value here, and the value is if we pass here an R value, so the R value just goes in without copying, and then we move from the R value. That's nice. But what happens if we move here something, if we pass to the function something which is an L value? So the L value needs to be copied. And once it is copied, inside it is a local variable and we can move it, but we do pay for a single copy. And the question here, maybe it is better to get it as a const ref, because getting it as a const ref means that we would copy only if we need it here, and insert doesn't necessarily need to copy. In a way, it is similar to a talk given by Howard Hinant on the merits of copy and swap. Do not use copy and swap idiom. Copy and swap idiom is nice. The copy and swap idiom says implement assignment as a single operation which gets by value instead of 2 assignment operations, one for R value and the other for L value. And it works nicely. But Howard Hinant shows in Accu 2014 that it is a bit less efficient. Why? Because in some cases you will pay a bit more. You will have an extra move or an extra copy. In many cases it would be fine, but not always. And this resembles in a way. So the other possibility is to actually have an option getting L value reference and then doing the copy. Now this alone is not enough. If you only have this one, this is not so good. Why? Because if you only have this one, and we provide here, we send to the function, we pass into the function R value, then the R value is being copied, even though it could have been moved. So adding only a const reference is not the right approach. The right approach is having the 2. If we get L value reference, there is no other way but just sending to insert the actual copy. If we do have R value, then you can move. Or the same thing in a way is to have a single method which is based on forwarding reference. So T double ampersand here is of course not an R value. This is a forwarding reference because we have a double ampersand on a template parameter. Here we use the C++20 requires syntax to require that T is convertible to string because eventually we want to get strings or something that can be convertible to string. And inside we do forward, which means if it was an L value, just pass it. If it is an R value, move it. If we check the actual run, then we see that if we get by value, if you send an L value, you get an access copy, a copy that you didn't want. If you send an R value, you are fine, but still you pay for the L value. If instead you have a const reference, you pay for a copy for R value, which you didn't need. And the two last options are the better approach, either to have a const ref and R value or have a forwarding reference implementation, which again is in a way the same as don't use the copy and swap idiom. Because the copy and swap idiom says get by value and then forward, and you have a single assignment, nice, but not so efficient. We are ready, I think, for the next question. Let's go for it. What's wrong here? This is a very short piece of code, and still we see here something not so good. And the options are the constructor isn't explicit, or we have a potential inefficiency, or there is a bad use of char star, or a potential leak. Since it's quite a short piece of code, I think that we'll give you a bit less time here, so 5 more seconds. And hurry up. Let's see the results. Most of you are saying that there is a problem with the constructor not being explicit, and this is also what I think. And why is it a problem? It's a problem because once you have a class and the constructor is not getting the full state of the object, the constructor is getting some configuration which is not the full state of the object, the constructor should be explicit. Because otherwise you are ready to create an object via casting while you're not getting the full state of the object. Suppose that vector would allow creating a vector from a number implicitly. So you could write vec equals 7, which now you cannot do that because the constructor of vector is explicit, and this doesn't seem so nice. Okay, but the bigger problem is that you could even send 7 to a method expecting a vector or a const reference to a vector, which is not so good. So if your class, if your constructor doesn't get the full state of the object, like for example string constructor getting char star is not explicit. And that's good, because allow is the full state of str. If I meet a string which was initialized with allow, I know everything that I need to know about the string. If I meet a vector which was initialized with the number 7, I know something about the vector, but not enough. And the right approach is put explicit on a constructor which does not get the full state of the object, and thus you preserve the strict attributes of the class. You do not allow casting from the simple type to your object. Okay, we're ready, I think, to the next one. And suppose that we got this code and we take a look at it. Assume that there is a good reason, there is a disclaimer on the side. Assume that there is a good reason we do not use here smart pointers. So the answer is not, oh, I know what the problem, you're not using smart pointers. Suppose that we implement here something which is our own version of a smart pointer or something like that, and we cannot use smart pointer for a certain reason. So what is the problem which is not, you are not using smart pointer here? Code doesn't compile, or PTR, which is our own, our single data member here, PTR should be mutable, or code breaks logical const, or maybe code breaks physical const. I remind you that the correct answer is the answer that I believe is correct. I'm saying that because, yeah, in a way, you can select here more than a single specific answer, but I think there is one which is probably better, probably the most right one. So let's give you another 5 seconds. And we can share with you the results. Most of you are saying that there is a problem here with the logical const, and you are right. The problem is that the code compiles. The code compiles, even though we have here two methods which in a way expose or change actual values in the class, actual values of the object, although they are declared const. And the code still compiles. Why? Because the compiler is preserving physical const. And the physical constness here is on the pointer, on the address, not on the content. And we either return the content by reference, allowing the user to change the content, or we assign something into the content, not into the address. We do not change the address. If we add const on the last two, then it would be compilation error. Okay, adding const to the last two would be compilation error, but adding const to the first two compiles, but is smelly. And I told you at the beginning that I'm teaching. I'm a lecturer after being in the industry for many years, and we do see such errors in juniors code, but also in the industry, where const is not present where it should be, or it is present where it shouldn't be. And eventually the purpose of const correctness is to correctly express what the code does. So adding here const and saying, but it compiles, is not the right approach. It compiles, but it is smelly. Okay, so we talked about logical const. We should also say something about const iterators. Using const iterators correctly, again, preserves const correctness in your code, so do that. Same thing goes with const smart pointers. And I do see many cases where the const smart pointers put the const in the wrong place. Putting the const on the shared PTR or on the unique PTR probably, usually, is not the correct place. Usually you do not want to pass a shared pointer which cannot move. You want to pass a shared pointer which cannot change the content, which is the first one, adding the const on the actual inner type of the pointer, and not on the shared PTR itself. So we should recall keeping const correctness is important because it widens the possible usage of function and it protects us from indeliberate modifications. Remember also that you have const expression, so if something is known at compile time, go for const expr for efficiency and correctness. Let's go for the next question. What's wrong here? We have here a method called default val. Default val is a method that gets a map and a key. And the key is in order to look for something in the map. Now, if I cannot find the key in the map, if the key doesn't appear in the map, then I want to have a default, the function is called get or default. This is the name of the function, get or default. So get or default returns either what it found in the map that corresponds the key, or if the key is not in the map, it should return the default value. And I'm getting the map by reference, const reference, for efficiency. I'm getting the key as const reference for efficiency, and I'm also getting the default value as const reference for efficiency. I do return the mapped type as const reference, again, for efficiency. So what can go wrong here? And the answers are, I will just read for you the answers. The map can be empty. Can it do some harm if the map is empty? B says you may have a dangling reference here. C says you have inefficiency in this code. And D says that the code is too generic. It's a bit complicated code. It's quite a simple code, but written in a bit complicated way. We get a map. We want to look for something. If we cannot find it, please return me the default value that I provide you. So we'll give you 5 more seconds. And let's share the results. And most of you say B, but there is some inconsistency here. We have other views. And the correct answer, or at least the answer that I picked, is indeed B. And why can you have a dangling reference? The question was what can go wrong here? What is wrong here, which means you may have a dangling reference. You may have a dangling reference because if you call the function and you send the default value as an R value and it is not found in the map, and you get back the result and you want to use the result later, so you get it by reference. Why do you get it by reference? Because you know that you are going to get something from the map. So you say, okay, I want to get it by reference. I don't want to copy value from the map. But eventually you didn't get a value from the map. You got your pineapple, and your pineapple is a temporary object. It's a temporary string, and it is being captured here by the const reference str without lifetime extension. And then when you use it on the next line, boom, you're using a dangling reference. Now this problem appears in Facebook code. You can find it if you are running the code with address sanitizer. Address sanitizer would find the problem and point at it, and then you can fix it. It was Louis Brandy from Facebook in CPPCon 2017 presenting this problem, which actually appears in Facebook code, and it told that what they did is to change the function to return by value. They say, okay, let's get the default value as a value, as not, and not as, let's get it by reference. Sorry, let's get it by reference, but let's return by value. But they also added after doing this fix, people got into the code again and changed again the return value back to reference in order to get back efficiency, and then they got again dangling reference. So they added into the code the comment saying, we know that you can use by reference here for efficiency, but we have bug if you are getting the type into a const reference, so don't do that. Don't change it back to reference. But the comment is not enough. The comment is nice, but someone can, again, ignore the comment and put, again, here the reference, and in some places in code, they get back the value, and the value is a temporary object being, at the end, a dangling reference. So what is the other possibility of saying, well, it's not the comment, it is something stronger than a comment. It's designed by contract. I'm saying what I'm doing. You cannot change it so easily. What can they do? Well, they can do something maybe a bit better. Can we keep const reference and still be safe? Can we have const ref and do not allow you to send the default value as an R value? And the answer is yes, you can. You can have two methods. One that returns const reference and gets the default value as a reference. But then you want to disallow the default value being R value. So you declare also the default value as R value and delete it. So by declaring the deleted version of the R value, you actually forbid sending R values, which means that the default value should be created one line before, and then you can use it as a variable that has a name that is which is an L value. And this is quite a simple solution in order to avoid the dangling reference issue. There is a chat message here. Let's see. Could we set this overload to return by value? That's an interesting question. Can we have, instead of a deleted function, have the two functions, one getting the L value, the other one getting the R value? Well, this is possible, but I would say that it would, in a way, preserve the inefficiency. It might be that it is better to tell all programmers, you need to send the default value as an actual variable so we can get back the result as a reference. Otherwise, we do allow to send by value or R value, but then we allow you only to take the return value by value, which is possible. So I guess in order to preserve efficiency, we have only the first one and delete the second one. The question was, can we have both implemented? And yes, this is a legitimate overload. Brandy Louis is on the same Louis Brandy, sorry, on the same talk, also presents the problem of dangling reference returned from a shared PTR. Suppose that you have a shared PTR and then you dereference it and get back the reference without holding an actual shared PTR. It might be that the shared PTR is now dead. So you should take great care when getting reference from shared PTR, or the same also for unique PTR, okay? The same thing. Suppose that you do make unique, and at the same point of doing make unique, no real reason for doing that, but I did see some junior code doing that, which means I need a location, let me hold the allocation, and for the worst case, it seems like a leak, but it is not a leak. It's a dangling reference because the unique PTR is being dead on the same line. So don't do that. And we are ready, I think, for the next question. And in the next question, we have three loops. We have here a range-based for loop, each of which is going through a string, trying to extract characters. The first one is trying to extract characters from a temporary string. The second one is trying to extract reference to character from a temporary string. And the last one is trying to extract characters from a string returned from a temporary object. And the question is, what's wrong here? We have four answers. All three loops may be using a dangling reference, or maybe only some of the loops are bad, but some of them are okay. For example, B is saying that A is okay, but B and C may be using dangling reference. Answer C is saying that A and C are okay, but B may be using a dangling reference. And D is saying A and B are okay, but C may be using a dangling reference. So what do you say? You're quite fast. I think you got into it. You hesitate now much less. So we'll give you 5 more seconds and reveal the results. Okay. Most of you are saying that the problem is with the loop at C. So most of you are saying D, but I see that there are many answers here which see some problems with other loops, and the correct answer is D, indeed. Let's take a look. When you create a temporary object on this side of the loop, it is being held by the loop. It is being extended. The lifetime of the object here is being extended, being held by const reference. Something is holding this part. Again here, but not here, because if person John is a temporary object, and the method returning its name returns the actual reference to the inner name inside person John. When we run through the loop, person John lifetime was not extended, which means person John on the last loop is gone while we loop, which means the name returned a reference to a dead John. Don't do that. So the problem is that lifetime is extended only for the actual object that we loop on, but lifetime is not extended for something that we use in order to loop on something else. And this is a known problem. It even has a language proposal to fix it, to change the behavior of the language so it would not be a dangling reference, but it is now. If this proposal would be accepted, so yeah, it would change. It means that it would change, and any proposal needs to say, well, if we change something, maybe we hurt something. So probably no one actually needed the behavior of using a dangling reference. So this kind of a change in the language is probably not something that would, I would say, create bugs on actual existing code. So there is a proposal out there, but the proposal is still a proposal. Don't do that. Okay, so again, the problem is with the third loop. You cannot loop on something that is a result of a temporary object. If, by the way, name returns the name by value, then you are okay. But most probably, name returns const ref to the name because it's more efficient. So most probably, this loop is looping on a dangling reference. And by the way, I say to my students, you know that when you loop on a dangling reference, the problem is that the code compiles and works perfectly. It looks fine because the memory is there, and it's not mine, but somehow the code even runs perfectly until we reach production on the busiest day of the year. So these kind of errors are quite hard to locate if you don't see them in code review or static code analysis. Debugging would not necessarily, or testing would not necessarily find it. You have to be quite careful. Ready for the next one? Okay. What may go wrong here? So the story is, we have two classes, derived and base. And for the simplicity, derived is the derived class and base is the base. And foo wants to get a base parameter. But suppose that at a certain point in code, base is not known. Okay, suppose that we have derived and somehow derived is known, but I'm sorry, base is not known. Derived is not known. Derived is only an incomplete type. We only have a forward declaration for derived. for some reason. So when we try to call foo with D, we get a compilation error because we cannot use polymorphism on incomplete type. The compiler says, okay, I saw that there is a class called derived, but I don't know the relations between derived and base. So for some reason we say, you know what, compiler, let's be friends. I will help you. How? I will do the casting myself. I will call foo and reference cast D to const base ref. And the question is, what may go wrong here? The compiler was a bit reluctant. He said, I don't know derived, it's incomplete type, and I cannot call foo. So I said, okay, you know what? Eventually you're going to call foo and treat D as a base, because foo is trying to get, is expecting base. And I know that derived is derived of base. Okay, what can go wrong here? And the answers are, base might be abstract, you may have a runtime bad casting, compilation error, or infinite recursion. And again, I would say this is something that might actually go when you try to do things fast and you say, okay, the compiler got me a compilation error, so how can I fix it? Okay, let's do the casting, because wait. Okay, let's reveal the answers. Most of you say B, and B is actually the correct answer. And the problem here is that, the problem here is you may have all sorts of possible problems. It might be that at a certain point, derived decides not to be derived from base, but actually to be derived from base 1. And the code would still compile. Because once you say, I want to be a reference of something on incomplete type, the compiler just says, okay, it's like a pointer casting. It's like a reinterpret cast. And another problem is that it might be that, yeah, okay, I'm a derived of base, but with multiple inheritance. And I have also another base, base 1. So the compiler, not knowing the actual derived type, would not calculate the correct reference. The actual address would stay the same as the address that I'm sending, which is not the actual address. So here we have a problem with calculating the actual address that I'm sending. Here we have a total different problem which says we still compile, even though I see that there is a question and some answer in the chat. Thank you. Even though that we changed the base. So the message is, don't use C-style casting. And I did see this problem in actual code. And once there was a change, and in that occasion it was adding a additional base class, something broke, and it is quite hard to find the problem. And eventually you say, oh, somebody did here some nested casting. Don't do that to begin with. Use either static cast if you know the actual type, but then it is still being checked at compile time, or dynamic cast. Both require the actual type to be known at compile time, and it cannot be an incomplete type. Going to the next one, what can go wrong here? Let's do it quickly. Using meters equals double. Meters distance is 7.5, and I'm calling do something with distance. What is the problem? Maybe we have a measurement units going wrong, maybe casting issue, maybe we do not enforce type, or all the above. A hint, well, the image on this slide is a hint. Okay, let's give you 3 more seconds. Hurry up. Okay, most of you say D, and indeed, D is also my answer. And the problem here is that using or typedef is not strong type. It is not strong type. You want to use strong types? Use strong types. It can still go through casting. It can still be used as a fit. The compiler doesn't check for me. You want the compiler to check for you? Use user-defined literals. Use actual strong types, for example, from Joe Bocara named type library. And then you have an actual meter which cannot be replaced with something else. For example, I have many bugs with student works that when sending X and Y, there is a single point in code where X and Y are mixed up or swapped. Go figure. Now, if X and Y are strong types, you cannot send X as a Y. Both are coordinates, but still, X is an X and Y is a Y. Same with width and height. They are the same, but you do not want to get mixed when sending them to a function. Structs are also not strong type. They are not a strong type. Not using, not alias, just an actual implementation of templated strong type. There is a way to do that. Why struct is not a strong type? Because you can create a struct without saying what are you creating. So if you have a struct with an explicit constructor, then you're going for a strong type. So go for name type. Take a look at Joe Bocara named typed library. It actually crashes. Both the Mars Climate Orbiter and the Ariane 5 crashed because of not using strong types. For the Ariane 5, it was for getting a bigger int into a smaller int, 128 into a 64-bit. For the Mars Climate Orbiter, it was measurement units. Both could be avoided by using strong types. And the industry is going to strong types. More and more projects are using strong types. There are libraries for strong types. There are talks talking about strong types. Use strong types. Next one. Are you ready? What will be printed here? And here are the results. Here are the options. We know that foo of 0 should return foo of 0. It is told that foo of 0 should return max int. Okay, so if foo of 0 returns max int, and then we calculate y, which is x plus 1, and then we ask, is x smaller than y? Would we print x is smaller, or y is smaller, or equal? Or maybe none of those. Let's give you 5 more seconds. You are much quicker now. You got into it, you read the code, you read the answers, and you select. And most of you correctly say that there is here something that can print anything. Why anything? Well, if we have max int and we add 1 to max int, adding 1 to max int doesn't overflow to minus something. It is undefined behavior. It is undefined behavior because signed integer overflow is undefined. Don't have undefined behavior in your code. Look for undefined behavior. If you have undefined behavior in your code, it means that maybe it works. Maybe with another compilation flex it would not. Maybe if you play with optimization, the optimizer will just throw the code or not. If you move to another compiler, so undefined behavior is undefined. Don't play with it. There are many talks, many resources on undefined behavior. You can browse it. There are many talks in CPPCon on undefined behavior. You can just look for it. Also in Accu. And it is important. It is important to note that your code should have defined behavior. So, for example, if you are working with numerics, make sure to work with safe numerics or to make sure that you do not overflow. It's important, especially if you are sending orbiters or satellites or anything that needs safe numerics. Let's go for the next one. What's wrong here? We have a stack. In the stack, we want a push, and the stack is using a vector inside. So what does push do? Push gets t, double ampersand, and then it forwards t into the vector because we want to push back the value into the vector. And the answers are, well, t double ampersand, the first answer says, is not a folding reference. Thus, you get compilation error. The second answer says t double ampersand in push is not a folding reference. Thus, we support only push of our values. C says push may add to the vector a dangling reference. And the last answer, D, says that push may inefficiently copy when it can move an item into the vector. What is your answer? Whoa, you are quick. You really got into it. You read the code, you think, you see the answers, and you type. So we'll give you 3 more seconds. Hurry up. If you're not sure, just guess. And most of you are saying D. Push may inefficiently copy when it can move an item into the vector, and this is not the correct answer here. The answer is D. Let me explain. T double ampersand here is not a folding reference. T double ampersand here is an R value reference. Why is it an R value reference? Because T is not the template parameter of the function. It's the template parameter of the class itself. When we call push, T is known. T is known. T is either int or string or any other type, but it's not a template parameter. So the double ampersand doesn't fall into the reference collapsing rules. It is R value reference to the actual type. Now, once it is an R value reference to the actual type, forwarding will actually forward. It will be efficient, don't worry. But it will not support L value. L value would not be able to go in. So we have some kind of a crippled stack. You can insert or push into the stack only R values. But suppose I have something which is not R value, sorry, make it an R value or just move it. But it's a problem. If I move it, I have, invalidating something which I didn't want to. So your interface is a bit problematic. You do not support L values. Okay, so let's see how to do that properly. Well, the proper way is to have 2 functions here. One that gets an R value. This is an actual R value. It is not a folding reference. And the other one which gets a const L value reference. The first one would move, the second one would just copy. Or you can take them both into a single function which actually do get folding reference, because here U is an actual template parameter of the function itself. Okay, let's go for the next question. We are still with the stack. We are still with the stack holding a vector, and now we are taking a look at pop. And pop wants to pop an item from the vector and return it, but because we know that the item is going to die, we just move it outside. And the answers for what's wrong here are, well, pop returns a dangling reference, or B, pop moves from a dangling reference. Code would be okay without the call to std move. Or C, pop is an undefined behavior. Moving out from a vector is impossible. You cannot move out from a vector. Or D, the reference E is being invalidated once we call pop back. This is a tricky question. So we will not give you much time because it's tricky. Eventually, you will just read it, think about it, and maybe you might just guess, but think about it. Let's give you, I would say, 20 seconds. What is the problem with the current implementation? Okay, so the actual problem, as most of you correctly say, is that we use an invalidated reference. So it's kind of a semantics. It's not a dangling reference, because once we call back, then we get reference, this is fine, reference is live. But when we call pop back, the distractor is being called on the last element. Now the memory there is still, vector doesn't shrink. So we can access the memory there. But the memory there doesn't hold the actual object. So it's an invalidated reference in a way. So we cannot use it. We can go to this place in memory if we want, but we cannot use it. And even if we do not do std move here, even if we just return E, still the same problem. Same problem. Okay. By the way, usually there is no need to call std move when you return. Suppose that move here was required or was okay. Should we do move here or just return E? And the answer is move is not required when you return an X value, a PR value or an X value. But here we try to return something that the compiler sees as an actual L value. So if you want to move, you need to say move. The code is problematic here. This is not right code. But if you do need, so yeah, you in a way wanted to say move in a way. Okay. We are to the next question. Okay, this is the proper way. The proper way is to move first, then pop back. It's okay, we have a copy here, and then return E. And E here doesn't need the std move because E is being moved automatically because it's an X value. It's an expiring value. It's a local variable. Okay, let's go for the 18 question. Conditional assign. Conditional assign gets a Boolean condition and two variables. It assigns to A1 only if the condition is true. And the question is, what can go wrong here? The answers are potentially wrong method call, or potential self-assignment, or infinite recursion, or maybe I just skip B saying dangling reference, potentially. We'll give you much less time because we are on the tip of the edge of the talk. Let's give you 10 seconds. Okay, you're quick. And most of you are saying C. And the problem here is that potentially you are calling a wrong method, because when you call A1, assign A2 to A1, if A1 is the derived object B, it would not call assignment of B. Usually the assignment operator is not virtual. The default assignment operator is not virtual. Be care of calling something, especially operators, which you in a way think that you know how they work, but in this case it's quite confusing. It's not a virtual call. And anyway, it's some kind of a similar case of object slicing. So beware. You call here the assignment of A, even though if you send B reference. Let's go for the next one. Skipping a few slides. And 19 questions. Shared PTR, two shared PTRs. What can go wrong here? Let's give you another 5 seconds. 5 seconds, you have to be quick. 3 seconds. And you are going to reveal the results. Most of you are saying that there is a potential memory leak, and this is the correct answer. And the problem here is that once two resources hold each other, they would not be released. You need to go through weak PTR or other solutions. But once one of the resources is holding a weak PTR to the other one, then it should be okay. So let's get ready. Last one, last option to get points. Are you ready? Here it comes. What's wrong here? And we especially focus on this line. The problem is here. And the answers are, we have here a potential memory leak, or redundant copying, or creating an unjoinable thread, or thread is not copyable. What the problem that you see here? What is the problem? And because we are on the last item, we'll indulge you with some more time. Let's give you 20 seconds. Last option to earn points. What is the problem with this call to thread? And most of you answered B, there is here redundant copying, and you are correct. Why do we have here redundant copying? Because when you pass const ref to a thread, you go through decay, there is a copying. How can you avoid that? By asking to get an actual const reference. Don't forget using std_ref. And if it was a reference which is not const, no problem, the compiler will catch us. The compiler will ask us to add ref, because without ref, I cannot get ref on the other side. But const ref is created on temporaries. So temporaries, const reference, hide the creation of temporaries. Not only here, but also on the first question that we saw when we started to talk. Remember the map? Looping on the map, key was not const, but we got const ref. Const ref is hiding the creation of temporaries. Take a look. Are we sending here an actual reference, or do we think that we send a reference, but actually we send a copy? Take care of that. Okay, let's count the points. So, score summary. Those of you who got 18 to 20 points, those of you, is it you? You probably wrote so many bugs, which made you the real C++ pro you are. Ask for a raise. You deserve it. Those of you who got 12 to 17, you're good. Remember that Bjorn itself rates himself 7 out of 10 in C++. It's not a rumor. He said it's true. Yeah, he said it. You got 6 to 11. Okay, you're a bit rusty. Consider moving to Rust. And if you got 0 to 5, don't feel too bad. But be sure to get your code reviewed, especially if you're working on life-critical systems. Many thanks. I'll be around. If you still have questions or comments, meet me at the lounge. I'm not sure that we have time for questions. Tim, do we have time for questions or comments?
We are effectively out of time, but I think we can have one question if you want.
So, if there is any question, if somebody wants to get unmuted and ask or comment, or to raise a comment or a question in the chat. Many thanks all. Thank you for the active participation, and see you around. Tomorrow I'm giving another short talk, a 20-minute talk on something that is related to type safety. It is a talk about the point challenge, how to return different results from the same operation. And again, it relates to type safety. So if you want to hear about type safety, look for my talk tomorrow on the point challenge. It is a 20-minute talk. See you around. Thank you all.